We are on page 11.
Okay.
We are still in section 3. What we did the other day is we talked about calculating and interpreting residuals, and then we looked at a residual plot. We talked about how you want a residual plot to be random, and that shows you that your regression line is a good fit to the data. And I showed you how to do it on the calculator. We had to go through all those steps and find the residual list. And then lastly, we talked about whether or not an observation is influential or an outlier. Two things that we are talking about today are the coefficient of determination and the standard deviation about the least squares regression line. These are two numeric measures, and I'm going to tell you how to find them, but more importantly, how to interpret them. The interpretation is pretty much a sentence I'm going to tell you that you're going to memorize. Okay? Okay, good talk. Coefficient of determination. Okay, R is the correlation coefficient. You guys know that? We did that in section 1. It tells you the strength and direction of a linear relationship. When you square R, it's called the coefficient of determination. So R is the correlation coefficient. R squared is the coefficient of determination. And you need to memorize that difference. R squared tells you the proportion of variability in Y that is attributed to the approximately linear relationship between X and Y. So write that down, then we'll talk about it. Okay, R is always between what and what?
Negative 1 and 1.
Negative 1 and 1. So then R squared is always between what and what?
Negative 1 and 1. 0
and 1.
Yeah.
0 and 1, right? So R squared is going to be positive. If your R value is 0.8, what is R squared? 0.64. Okay, so if your R value is 0.8, that tells you that there is a strong positive linear relationship between X and Y. R squared being 0.64, in simpler terms, it means 64% of the time Y changes because X does. So it's saying 64% of our data is attributed to that line. And then the other 36% of the time, Y changes for some other reason, not attributed to X. Does that make sense? So the higher that R squared is to 1, the stronger our relationship is. It means Y changes because X does. The closer that R squared is to 0, it means that Y is changing for other reasons that are not attributed to X. So there's a bunch more error or other factors that are involved. Okay, the variability in Y is best explained when your observations fall close to the line. So if your observations are close to the line, Y is changing because X does. Okay, this is the analysis that you have on page 12. Sorry for all my underlining. This is what's important, the R squared value. R squared should be a proportion though. So if I asked you what's the coefficient of determination, you would tell me that R squared is 0.717. I don't want 71.7%, I want 0.717. There's also this R squared adjusted. We will never use that. Any of the statistics that say adjusted, we're not going to use. Besides finding R squared, I'm going to ask you to interpret R squared. So if you remember this data set, this is the one where we looked at the percentage of low-income students and the average ACT. So what I want us to do is interpret that value of R squared right now. So you would say 0.717 or 71.7% of the variability in Y, which in this case is average ACT, can be attributed to the approximately linear relationship between X and Y. So in this case, between percentage of low-income students and average ACT. So in simpler terms, this means 71% of the time, Y changes because X does. 29% of the time, Y changes for some other reason, some other factor. My honest best suggestion to you is to memorize this sentence. I want you to say it back to me exactly like I have it worded. Don't put your own spin on it. Don't put your own personality in the sentence. I want my sentence just regurgitated right back to me. Okay? So memorize this. Questions on coefficient of determination. This is really, really important. It's, well, specifically that you know the difference between these two. So I'm never going to ask you find R squared. I'm going to say find the coefficient of determination, which you need to know is R squared. If we went to find R in this case, would R be positive or negative? So if we took the square root of 0.717 to find R, positive or negative?
Negative, because C was negative.
The slope is negative, so R would be negative. You need to pay attention to that. Okay, more things on coefficient of determination. This is called the total sum of squares. Don't write this down. I'm never going to ask you to calculate that. This is called the residual sum of squares. Don't write it down. Never going to ask you to calculate it. This you need to know. You need to know this formula. So if I give you SS resid, the residual sum of squares, and I give you SSTO, the total sum of squares, you can find R squared. But I'm not going to ask you to calculate those two variables separately. This is a formula that you need to have memorized. So I don't know if you guys know this, but there's a formula sheet for the AP Stats test.
I did not know.
Okay,
That's awesome.
now you know. This formula is not on there. So this one you have to have memorized. Okay, you guys have, this is still on page 12? Okay, so you have this down at this analysis of variance. You have this total here, and then you have this residual error, and then you have the SS. So this number right here, the 632.4, that's your SS resid. That's your residual sum of squares. And then if you look for total SS, so this right here, the 2,233, that's your total sum of squares, SSTO. So if you did 1 minus 632.4 over 2,233.4, you should get 0.717, since that's our coefficient of determination. You need to remember how to find those. Got it? I believe on your homework, there's one question where I give you this value and ask you to solve for that one instead. So just know sometimes I'm going to ask for one of those two instead. Okay, that was coefficient of determination. Not that bad, right? Okay, awesome. Now we're going to talk about standard deviation about the least squares regression line. This is one of those things where you're just going to memorize it also. Okay, this is the formula.
Is there another page for this?
This is still on pages 11 as well.
That's good.
I'll make it work.
Like, is there room on page 14 at the bottom?
Are we going to use 14?
We already did 14? Just make it work,
Is
guys.
this enough room?
Yes.
Oh.
Yeah. So Brooke asked, bottom of page 12, is this enough room? Yes. This is enough room. You're going to write down the formula and then write down a sentence and that's it. But this is a formula for the standard deviation about the least squares regression line. It's the typical residual. So SE tells you the typical residual, the typical vertical deviation. It's always positive. Doesn't mean all your residuals are positive, it just is always positive. This is that output that you have. Again, on your output it shows up as S. So the symbol we use is SE, but on the output it shows up as S. So 1.7 is the typical residual. So I'm going to ask you interpret the standard deviation about the least squares regression line. So we're going to do that over here. The typical, remember residual is a vertical deviation. So the typical vertical deviation in the y direction, so that's ACT score. So the typical vertical deviation in ACT score from the least squares regression line. So the typical vertical deviation in ACT score from the least squares regression line is 1.71 points. So it has everything to do with y, nothing to do with x. So it's typically how far observations are from the line of best fit. If you want a really well-fitting least squares regression line, what has to be true about S? Or what do you want to be true about S if your line is a good fit?
Close to 0.
Yeah, it's close to 0. It's going to be small. It means your points fall close to the line. What about R squared? If you have a good linear fit, what should be true about it? Close to 1. Yeah. Yeah, look at that. We're done. That wasn't bad, right?